Hi guys, and welcome to the video on the introduction to rational expressions. So in this video, guys, we're going to go over the definition of a rational expression and how to cancel numerators and denominators and parts of them. This is essential for pre-calc. And you'll know you're successful when you can reduce a rational expression. So, some prerequisite skills that you need to have. Factoring out a greatest common factor. Remember we did this in Unit 3. Factoring trinomials. Again, we did this in Unit 3. So if you find yourself saying to your, if you find yourself thinking, man, I really haven't done that in forever. I don't know what he's talking about. Go back and look up those videos, the GCF videos and the factoring trinomials video, and just rewatch them. You don't have to take notes or do anything fancy, but just like watch an example or something. Hopefully, you can kind of get the gist of these skills by watching me here. But if you still find yourself saying, man, I don't know what he's basing this off of, take a look at some of our previous videos. And that's what they're there for, so that you can kind of revisit those skills, because you are going to need them for this section and this unit. And then you also are going to need to be able to simplify or reduce fractions. So let's get started with what is a rational expression. A rational expression is a fraction that has a polynomial in the numerator, the denominator, or both. Things you can do with rational expressions: you can reduce them, which is simplifying. You can multiply them, you can divide them, you can add or subtract them if you have a common denominator. And these are all things that you can do with other fractions, just like regular fractions, ones that are numeric only, like 1/2 or 3/6 or 6 out of 10. Like, you can reduce all of those fractions. And so let's take a look at what we have, like in terms of cancellation and other things like that. In order to simplify a rational expression, you divide it. You can divide out. When I say divide, I'm more saying along the lines of cancel. You can cancel out common factors, because this is, after all, a fraction. So the idea is that you have like 2/4. Well, both of those have a 2 as a factor. And so you can cancel out both of the 2 from the top and the bottom to reduce 2/4 into 1/2. So the idea then in rational expression world, if you have 2x over 4, you could reduce that to x over 2. And that's kind of the same thing. So we've reduced our rational expression there. So you're going to list out the factors of the numerator to denominator. You're going to look for any factors they have in common. And remember that when you factor something, it's all multiplication. You can then remove them via division. Really what I mean is you can remove them via cancellation. Oh man, I messed up my A there. You can remove them via cancellation. So you can cancel them out of the top, you can cancel them out of the bottom. And then that removes them, quote unquote, from the rational expression. And then you're going to rewrite without the missing factors. So you're going to, everything that you canceled out, you're going to get rid of it, and you're just going to you're going to like take it out of the expression. You're going to rewrite it with only the leftovers. So let's start with an easy one. These are considered easy because they're single terms, they're monomials only. In this situation, all you need to do is list out all of the factors and then see what they have in common on the top of the bottom. You don't have to do any of the prerequisite like factoring, because it's nothing but multiplication. So on the top here, I actually don't want to use an equal sign. On the top, you'd have 15 times an x times an x. And that's how you would make 15x squared when you write it all out with factors. On the bottom, you would have 25 times x. So on the top and the bottom, I know just through common knowledge that you can divide out a 5 from both 15 and 25. So I can cancel that out of both those. And I know that you can cancel, or I can cancel out an x here, and I can cancel out an x on the bottom. So I'm going to write the remainders. I'm going to write everything that's left remainder-wise. So on the top, 15 divided by 5 is 3. And that looks awful, so I'm going to rewrite it. And then I have another x left, so 3x. And on the bottom, I canceled out the only x that I have, and 25 divided by 5 is 5. So my completed rational expression is 3x divided by 5. So another example, reduce the rational expression. So here we have multiple variables, but this is all still one term on the top and the bottom. Both of these are monomials. So if I write an m and an m just to signify that they're monomials, because there's no addition subtraction. Things become binomials, trinomials, etc., when you introduce some addition and subtraction. So on the top, when I have monomials, all that I really need to do is like write them out. So on the top, I've got 5 times x times x. And then I'm going to write out there are 5 y's. So times y, times y, times y, times y, times y. And then on the bottom, and I know that seems kind of tedious, but it's the best way that I found for canceling. And then I've got 25 on the bottom, and I have an x and a y. So I know that top and bottom both 5 and 25 are divisible by 5. So I'm going to cancel that out, leaving me with a 1 on the top. I can cancel out one of these x's and one of these y's. So on the bottom, 25 divided by 5 is 5, and I removed the only x and the only y, so all that I have on the bottom of my fraction is a 5 left over. And on the top, I have a single x, and then I have 1, 2, 3, 4 y's. So it would be y to the 4th power, and then I could write that as x, y to the 4th, divided by 5. So here again, I have another rational expression. And so in this rational expression, it's still monomial on the top, monomial on the bottom. So all I really need to do is list out all of the factors. So on the top, I've got 42. On the bottom, I have 14. And then on the top, I've got x times x. And then I have 6y. So 1, 2, 3, 4, 5, and 6. And then on the bottom, I've got 5 x's because it's x to the 5th, so times x times x times x times x times x. And then I have 4 y's, 1, 2, 3, and 4. So what I can do now is go through and figure out what the highest factor, the highest number factor that I have between the two numbers on the top and the bottom are, and that's, so both 42 and 14 are divisible by 14. So I'm going to be able to cancel out a 14 from both the top and the bottom. And then I have 1 pair of x's, top and bottom, that I can cancel. I have 2 pairs of x's, top and bottom, that I can cancel. And then I have 1, 2, 3, 4 pairs of y's that I can cancel on the top and the bottom. So what's left over is, on the top, 42 divided by 14 is 3. And then I'm left with 2 y's, so it'd be 3y squared. And on the bottom, I'm left with 3 x's. And then 14 divided by 14 is 1, so I would just have x to the 3rd power left on the bottom. And that is my reduced rational expression. So the 3 rational expressions that we viewed thus far were all monomial divided by monomial. What happens eventually, though, is rational expressions become more complicated when you have binomials, trinomials included in your rational expression. So here is what I would consider a proper rational expression. 6x to the second minus 19x plus 3 divided by 4x squared minus 36. That would be what most people think of, what comes to mind when we say rational expression. I wanted to start off with a really nice uncomplicated version of it, though. First, this is kind of what you would expect of a rational expression. And in order to simplify it, you would first have to factor the numerator and the denominator to search for their common factors. When canceling, when factoring and canceling, it is incredibly important to remember that monomials cancel monomials, binomials cancel binomials, and trinomials cancel trinomials, and so on and so forth. And when I say that, I mean literally the exact same copy. So x over x can cancel each other because you have the same thing on the top and the same thing on the bottom. X plus 2 divided by x plus 2 can cancel each other out because it is literally the same thing on the top and the bottom. And then x squared plus 2x plus 1 could divide and be canceled by x squared plus 2x plus 1 because you have the same thing on the top as you do on the bottom. Remember that if it's not exactly the same inside the parentheses, inside that little nest, okay, you can call it a nest. I refer to it as a nest sometimes. If it is not exactly the same on the top as it is on the bottom, you cannot cancel it. You can't cancel half of it. You can't cancel parts of it. You can only cancel entire factors. And that's incredibly important to remember. It's so important that I wrote an entire slide on what to never do. You can never, ever, ever, super important, never, ever, ever, cancel things out like this. X squared plus 25 divided by x does not equal x plus 25. That's not true. It's never true. In this situation, what just happened was we canceled a binomial using a monomial. We can't do that. On the previous slide, I said you can only cancel monomials with monomials, binomials with binomials, trinomials with trinomials. Well, you can't cancel a binomial here with a single monomial. You would need a binomial to cancel it. You can't cancel parts of it. You can't cancel the x squared and the x because you cannot cancel specific parts. You must cancel the entire nest or nothing at all. So on the top, this whole thing with the parentheses would be a nest, and this whole thing would be a nest on itself. And because the nests are not the same, you can't cancel them. You must leave them alone. So let's take a look at a more complicated rational expression and then how we would go about simplifying it. So on the top of my rational expression here, I have x plus 3. On the bottom, I have x squared plus 12x plus 27. On the top, I can tell that's a binomial expression. On the bottom, I can tell that's a trinomial expression. Generally, you want to start factoring the expression that is higher, like has more terms. So you want to cancel any trinomials before binomials. You want to cancel or factor any binomials before you try to factor and cancel any monomials. So we're going to start with the bottom for that reason. It's got 3 terms. It's a trinomial. So that's going to be the most likely to have factors and cancel. So I'm going to start with the bottom. So here we go. I noticed that it's a quadratic trinomial. So I'm going to use the tried and true method that we learned. There's a ghostly 1 in front of x squared. 1 times 27 on the top. And then on the bottom, I'm going to put the 12. And then I've got x and x here. And now I've got to figure out what are the 2 numbers that are going to multiply to this and are going to add to this when combined. It could be add or they could subtract to it. It depends. And I am those are going to become my factors. So I'm going to think about some factors of 27. So 1 and 27, if those are added together, that would be positive 28. That's not going to work. So I'll do 3 and 9. So plus 3 and plus 9. So 3 and 9 together is 12 when added together, and they multiply to be 27. So on the top, I didn't factor the x plus 3, but I am going to put it in a nest. The parentheses, I'm just going to refer to it as a nest. On the bottom, so the bottom turns into x plus 3, the first factor on this side, and then the second factor over here times x plus 9. And so now what I can do is see that I have a nest up here of x plus 3, and I have the same exact nest down here of x plus 3, so I can cancel them. So I can cancel that, and I can cancel that, because it's being multiplied down here on the bottom. Now, what that leaves me with on the top of my fraction is a 1. I don't like that. A 1. If you happen to cancel everything out on the top or the bottom of a fraction, it reduces, quote unquote, to 1. So if you think about, like, if you have, oh my gosh, I can't draw a fraction bar. If you have x divided by x, that turns into 1. If you have 2 over 2, that turns into 1. That's exactly what's happening here. And then on the bottom, I have x plus 9, and that is my completely reduced rational expression, 1 over x plus 9. Okay, so here's an example where I have a trinomial on the top and a trinomial on the bottom. So I know that I'm going to need to factor both of them. The order is not important, but I do see x to the third power on the bottom, so I think that I will come back to that. What I am first going to do is I am going to go ahead and factor the top. So 1 times 24 puts a 24 on the top, puts a 10 in the middle, and an x here, and an x here. So if I think about the factors of 24, I have 1 and 24, that adds to 25. I have 2 and 12, that adds to 14. I have 8 and 3, that adds to 11. And then I have 6 and 4. So I'm going to put plus 6 and plus 4 here. And that adds to 10 and multiplies to 24. So the two factors, so I'm going to draw my fraction bar. The two nests, the two factors that I could put up top are x plus 6. And that would be multiplied by x plus 4. So now I'm going to take the bottom and I'm going to factor that. I realize that we did not cover how to factor cubics. So in the situation where you have a cubic, the first thing you're going to want to do is look for any greatest common factors that you can. And then, so I'm actually going to type that if I can. So where's my text? So first, try to factor out any GCF to reduce to a quadratic level. And then you're going to factor the quadratic. So the first thing that you're going to try to do is to factor out any GCF to reduce it to a quadratic level, and then you're going to factor the quadratic. So here, I realize that x cubed, x squared, and negative 20x, they all have an x in common. That's the GCF. So I'm going to reduce it. So I'm going to factor it to be x times, and then it would be x squared minus x minus 20. So now if I were to do the distributive property, I would go right back to having x to the third minus x to the second minus 20x, you know, if I did the whole distributive property. Now what I'm going to do is I'm going to take this thing in here, and I'm going to factor that the same way that I just did the top. So that's going to factor into negative 20 on the top, which means one of these factors is positive, one is negative. So I have x and x. and then it's -1 down below. So I've got to think of two numbers that multiply to be -20, one positive, one negative, and they combine to be -1. So that does tell me that the -1 number, the negative number over here, that needs to be the higher amount. So let's think about the factors of 20. So I've got 1 and 20. If 20 is the negative, I get -19. Okay, that's too much. I'm going to do 2 and 10. If 10 is the negative, I get -8. Again, that's too much. If I do 4 and 5, and 5 is the negative, then I have -1 when they are combined. So it should be +4 and -5. So the bottom factors into the expression x, because I still have the original x here, times, now this refactored, so this double factored expression on the bottom would be x plus 4 times x minus 5. So now I can look for any doubled up nests, any parenthesis nests that I have on the top and the bottom that are exactly the same. On the top and the bottom, I have an x plus 4 here, and I have an x plus 4 here. So I can go ahead and cancel them both. And what that leaves me with is on the top, I have x plus 6. And then on the bottom, I have x times the expression x minus 5. And that would be my reduced rational expression. All right, and then finally, reduce this rational expression. So on the top, I have a binomial, and on the bottom, I have a monomial. So I'm going to choose to focus on the binomial. I realize that it is not a traditional trinomial for quadratics, so the only real factoring that I can do in this situation is to see if I can remove a GCF. So I'm going to see if I can remove a GCF. So I'm looking at the top, and both x to the second and x have an x in common. And I really can only, that's the only thing that they have in common. So I'm going to factor that out. So if I remove a GCF on the top, I get x in a nest times x plus 1. On the bottom, the only thing that I need to do for a monomial, thinking back to the first few examples, the only thing that I need to do for a monomial is write out everything. So it would be 9x would be written as 9 times x. So on the top, I have an x. On the bottom, I have an x. So I can cancel this x with this x because they're the exact same thing. And then that leaves me with, on the top, x plus 1. And on the bottom, it leaves me with a 9. And that is my reduced rational expression. Okay, guys, that's it for rational expressions, for the intro to them. Let's remember that rational expressions are fractions that are polynomials. They have polynomials in the numerator and the denominator, and then we can perform all the same operations that we do on regular fractions. We'll be multiplying, dividing, adding, subtracting rational expressions in the coming sections. Remember that to simplify parts of a rational expression, they must be exactly the same. So the example that I'm going to give is that you would need to have x plus 3 over x plus 3. You could cancel that. That would be completely acceptable to cancel. What you cannot cancel, you can't do something like x plus 3 over x. There's nothing to cancel here, so there's no cancellation to be had. And then just remember that factoring is going to be back and play a major part in simplifying rational expressions. So not only is it going to be this section, but it's also going to be next section, or for the rest of the sections too, that you're going to need your factoring skills. And so if you're feeling rusty on those, even after kind of seeing me do them a couple times, you need to revisit Unit 3. And you need to do that kind of informally when you have some extra time. But other than that, guys, that's it for today's video. Thanks for watching, and I'll see you in the next one.